All right. So let's get this started. So then, first of all, a wonderful good afternoon and welcome to the absolute worst time of the day. So, of course, this is not there's a misunderstanding. Don't walk out of this talk just yet. I mean the after lunch talk, of course. Yeah, the after lunch session. That's the worst. The worst. Oh, okay. Different opinions. I feel like I've picked the worst time slot. So, the usual introduction slide. I'm Klaus Iglberger. I am a C++ trainer / consultant. So I, in other words, talk a lot about C++. I've even written a book about C++ called C++ Software Design. I organize the Munich C++ user group, and I do various things at various conferences. And so, based on the book, I usually do talks on software design. I talk about design patterns, I talk a little bit about architecture. That's pretty much what I do. And yet, for today, I've actually picked a different topic. Pretty, from my point of view, a more serious topic, because it's important to talk about this. So, just to open it plainly, C++ does have a problem. C++ has a safety problem. So you might have heard about this from various sources. You might have heard that, for instance, a couple of years ago, the NSA complained heavily that we are using C++ and actually told us that we should not, because it's not memory safe. Similar words came from the White House that also argued that for cybersecurity, we should actually strive towards memory safety. And even the European Union is pretty much saying the same thing, with not as drastic words, but the idea is pretty much the same. We have to strengthen our software. We should drive towards something that is safer by default. So, and then on top of that, there was a lot of bad press. Articles like this one that made people believe that all the problems that we have in software are because of C and C++. So, apparently C++ has a safety problem. Or does it? Well, to give a short answer at this point, yes, absolutely, but only if you still have the classic C++ mindset. So that's pretty much what I want to talk about. That is pretty much the core. But let's first start to talk about how did we get there. Now, you may that for historic reasons, C++ was very, very performance-driven. So whenever we did a decision in C++, for standardization, for the language as a whole, the answer was always do the fast thing. If you had to make a choice, performance. Sure, you might know a couple of different decisions. We could now mention std function, which kind of took the other way, but usually it's about performance. But there's a reason behind that, because actually it's always possible to make something that's fast safe, but it might not be possible to make something that's safe fast. And this is what John Cope said in this talk. This leads us up to this observation: yeah, they can build safe on top of fast, but they can't build fast on top of safe. What this means is that, given an API that does no domain or testing, one can build an interface on top of that API that adds any necessary checking, making it safe. And of course, this makes perfect sense. This is reasonable. Absolutely. And yet, again, that's just that there's no misunderstanding. This doesn't mean that C++ is fast. Now, to say it in the words of Chandler Carruth, C++ doesn't give you performance, it gives you control over performance. So it's not that because you're using C++, everything is fast. Oh, no, definitely not. You still definitely have to know what you're doing. You have to use the right tools. You have to use the right code, the right containers, data structures, etc. But if you do that, then it can be fast. But in retrospect, was it a bad idea to focus on performance entirely? Was it? Is C++ broken because of that? Do you really have a serious problem? So, at this point, I can really say no, absolutely not. But you definitely have to do some work. First of all, we have to do some work to continue to make the language safer by default. It should be simple. It should be easy to write the safe code, the good code, the correct code. But I think there is one thing that is even more important. That's a little bit what I'm dwelling here in this talk. I think even more important is that we just far better communicate how to program in C++ today. Because this is where we truly suck, unfortunately. And this is where all these problems come from. So, let's quote Herb Sutter, the current convener of the C++ Standardization Committee, who has dealt a lot with the safety issue lately. So in one of his longer articles, he says the following. The immediate problem is that it's too easy by default to write security and safety vulnerabilities in C++ that would have been caught by stricter enforcement of known rules for type, bounds, initialization, and lifetime language safety. So I'm using this quote because of an obvious statement about the known rules. Indeed. In C++, we have for decades accumulated wisdom how to use the language properly. And we have rules in abundance. Yeah, we have hundreds of core guidelines, for instance. And so, let's talk about a few of these best practices, about these rules for types, bounds, type initialization, and lifetime safety. So let's talk about the full riders of the apocalypse. But I'm throwing in one more. I want also to talk about UB. And now, okay, now you're thinking my knowledge is broken. 4 riders of the apocalypse, 5 things. Okay, I think there's actually 5 riders of the apocalypse for now. So perhaps I'm fine after all. So let's talk about these 4 in this order. And I'd like to just start with bounds safety. So in order to illustrate this, let's take a look at a slightly longer code example. So this code example has to do, first of all, with countries. So a country has a name, has a capital, has an area in square kilometers, and a number of residents in millions. Okay. So then there is a continent, which has a name too, but then also many countries in form of a vector of country. All right. So and now there's just one function called print 5 biggest countries. Okay, so in this function, I now first of all get all the continents. Get continents with countries is the function that just gives us a vector of continents somehow. So then I start with this constructor. Now, what does this do? Of course, we don't have a couple of minutes until you've really browsed the code, read through this, made up your mind, and give an answer. So in short, what this loop is doing is it traverses all the continents, then all the countries in the continents, and then all these countries are put into the vector, but in a certain order. Largest country first, smallest country last. So I guess if I would have take a look at this for, say, 2 minutes, scarily, some people probably have given me the right answer. But most people probably would have taken 5 minutes, 8 minutes. It would have taken a considerable amount of time to understand what this is actually doing. Okay, then we continue. Then we actually create another vector called 5 biggest countries from the, 5 biggest countries. And I do something with these countries, these 5 biggest countries again. So another for loop. And again, I could ask you, what does this do? And again, I don't want to wait for a couple of minutes until I get the right answer. What this loop is doing is, reshuffles, or resorts the 5 biggest countries by the number of residents. Highest number of residents first, lowest number of residents last. But again, this would have taken a couple of minutes until somebody would have figured out, what is in the middle is doing is actually a swap, and then there's a comparison based on residents. So it would have taken 5 minutes, 6, 7 minutes until I would have gotten the right answer. So, it's complicated. Just to print the 5 biggest countries. But now, there is something actually far worse going on, and you might just notice this. Here. +5, up to 4, less than 5. So for your further reference, this is actually the UB smiley today, okay? This code works if we have at least 5 countries in this vector. If there's no 5 countries, it's undefined behavior. So we reach out of the vector and anything could happen. So this is just not good. It's complicated, it takes you time to understand that. It's difficult in the code review, it's difficult in the maintenance. Yeah? If you have to change something, you first have to understand it properly. We can do better. Actually, we can do far better today if we just use a different style of programming. So here it is again. The same function does exactly the same thing, but this time it actually fits easily on one screen. So, print the 5 biggest countries. We start again with the same vector of continents. And now we pick this vector of continents and we first transform it to the countries. So now what we have is, at least logically, a whole bunch of vectors of countries. But it's several vectors, logically. We need one vector of countries, or want to have one, so we now join all of these vectors. Again, logically. Right now, nothing has happened. This is just an expression of what you would like to do. But then all of these countries are actually stored in a std vector. So this countries here is a std vector of countries. Nice, isn't it? And I guess even if you wouldn't have used the style before, even if you wouldn't have seen that, I guess you would have very quickly guessed what this is doing. It extracts all the countries and stores them in a vector. So then we sort with a sort. It's not hidden in some for loop. It's a sort call. You now know what this is doing. It's very expressive. And this is even faster. Yes, indeed. Before it was an insertion sort, which is actually not particularly fast, but this now is most probably an inter sort. Way faster. Good. And then we have all these countries, and we now take the first 5. So, of course, now you're alarmed. 5 again. What if there's fewer? Relax. The take just takes it maximum 5. If there are 3, it just takes 3. If there are 4, we have 4. And if there are 5 or more, well, then you have a full set of 5 countries. We just sort it again. Again, nice and expressive by means of a sort function call. Everybody understands what this is doing by just looking at the code, and then you can print that. This is how I want the code to be. This is great. This is the Ranger style. So it's much shorter. As I said, it fits on one screen. I don't have to scroll up and down. It's way simpler. It's faster. There's no manual handling of any kind of indices, iterators. And this is why it's so much safer at the same time. And so you don't have any bound safety problem. It's impossible to do this. Amazing. So this is pretty much what I envision. So, and this is what C++ is today. This is exactly what we want to use, what we have to use today in order to make this safer. And this is perfectly aligned with C++'s philosophy. Absolutely. This is building safe on top of fast. That's what it is. And this is how it should be, I believe. However, now many of you say, Klaus, this is not news. And no, it isn't. This is what we've been doing for decades. So perhaps some of you remember this particular talk and the person who gave the talk. So this is Jean Perrent. The talk is called C+ Seasoning. In his talk, Jean makes a very kind of provocative statement that, however, I believe has affected the community quite severely. If you want to improve code quality in your organization, I would say take all your coding guidelines and replace them with a one goal. That's how important I think this one goal is. No raw loops. This will make the biggest change in code quality within your organization. So, no raw loops. Now, by the way, just that there's no misunderstanding, John doesn't say that you should never write any loops anymore. No. This is also one of these misunderstandings. He says that you should not write loops that people don't understand anymore. Simple loops, short loops are perfectly fine. But way more often, these loops got out of hand, nobody understands them anymore, and suddenly they cannot be maintained anymore. That's what this talk is about. And this talk was not just yesterday. This talk was in 2013, 12 years ago. But then, to be honest, the idea, this philosophy, is of course even older. Algorithms, which he now highlights here, were not invented just in C+11. We have them pretty much since 1994. This is when they were added into the C++ standard. And so this philosophy is so much older, and still it has not arrived everywhere. So, which means this is the safety takeaway number one: no raw loops. That's what we should all do. This is how it is. This is the language. Yes, it should be. But of course, now people start to complain. It is so complicated. I would like to use it, but my colleagues won't understand my code anymore. This will probably reduce performance, right? And of course, I'd rather stick to what I've used the last 20 years. Of course, sure. If you don't want to, it's unfortunate. But there's also something that people very often complain about. Oh, I cannot use C+20 yet. And as I cannot use ranges, well, that statement definitely isn't true. You can always use ranges. So in the worst case, just fall back to the original implementation of the ranges. So this is ranges v3. And you see here, ranges v3 is useful for, or usable with C+14, 7020, and of course beyond. So pretty much all of us today can use ranges if they just want to. But then there's another problem. Unfortunately, in the recent years, people have started to talk to ranges down for various reasons. And so you might have heard that C++ ranges just don't work well. Okay, sure, it's not perfect. There are a couple of issues. But if you don't want the standard ranges, by now we have 8, 9, perhaps even 10 different ranges libraries out there. And so one that I would recommend, for instance, is the Flux library, written by Tristan Brindle, also findable. So here, Tristan TC Brindle Flux, easily findable, and it's fast, it's efficient, and very similar to ranges. So it's not really about which library you use, it's that you use that. So and this is what Tristan himself also says. It doesn't matter which kind of ranges you use, but you should use ranges. And so, in the end, I believe it's a mindset problem. It's a people problem. No matter what the problem is, it's always a people problem. So, bound safety. If you do it right, there is not really a bound safety issue. And so let's take a look at undefined behavior. Again, I would like to start with an example. Let's take a look at this generate prices function. So generate prices returns a vector of double the prices. We have a start price and a number of prices that we want to generate. Okay, so first of all, we start with a vector that is sized according to the number of count, and then we put the start price at index 0. Good, then some more stuff happens. We compute a next price somehow, based on the start price, and then we generate the resulting prices, the next and the new prices right after the first price, the start price, so, and return the prices. So, of course, we want to test this function, so there is a test generate prices function. Test generate prices first generates prices, creates the according vector with the expected prices, and then we just compare, for instance, with a stood equal, no raw loops, remember, and we just check that this truly is the same, that everything works. We return true or false. So then in main, we can truly assert that for a couple of examples, this works. Good. So, however, of course, some of you are smart. Some of you looked at this code and immediately thought, wait. What if count is 0? Again, a bound safety issue. Okay, I admit, again, kind of the same problem, though this time I'd like to approach this a little differently. So let's fix this in a different way, because we, again, can do better. Let's just add a keyword. Let's extend generate prices with constexpr. Why not? Doesn't hurt, right? It's a single keyword. Kind of sounds like it's potentially reasonable to do this at compile time as well. Then test generate prices. Well, we could use a const eval. No, not because we have to, but because we can. Now, this is a function that we can only use at compile time. And so for that reason, in the main function, assert doesn't really work anymore. Let's use a static assert as well. So, and now something extraordinary happens. You will love this. The code does not compile anymore. Compilation error, GCC 14.2. So it starts with a non-const condition for static assertion, blah, blah, blah. And then here, the explanation, error, dereferencing a null pointer. Whoa, amazing, right? So the compiler tells us that we pretty much have undefined behavior in our code. Tells us at compile time. Amazing. So, and pretty similar in Clang. Static assertion expression is not an integral constant expression, blah, blah, blah. The usual stuff that you get if something constexpr doesn't work. But then the explanation, assignment to dereference null pointer is not allowed in a constant expression. Amazing. Absolutely amazing. But not a coincidence. This has to happen. That's what the language specifies. So in the C++ standard, it's written explicitly. Evaluation of a constant expression never exhibits behavior explicitly specified as undefined and then it names pretty much the entire standard. Amazing, isn't it? So a single keyword suddenly helps us to get rid of all undefined behavior. If, and that's a pro tip that also Jason Turner gave last year, if we actually run this stuff at compile time. That's kind of the key. So it is pretty usual now that we test both at compile time and runtime. Yeah, both is important, but due to constexpr, we can do the compile time part. But this is something that Jason has been talking about for decades, I would say. It's not quite a decade yet. This was in 2017. So he and Ben Dean talked about constexpr all the things. And apparently there was a lot of wisdom here. Yes, perhaps we can now do some compile time thing in our product. But more important, way more important is that there's absolutely no undefined behavior left if you properly do that. And so that specter is pretty much vanquished. There is no undefined behavior anymore if you probably do this. And by the way, many people in the committee, just naming also Hanna Duzikova, many people have voted for making more and more stuff constexpr. And I believe that C+26 now will be the first standard where almost everything is constexpr. Almost everything. Yeah, you can do whatever you want to at compile time nowadays. It is amazing. So, safety takeaway number 2, constexpr all the things. And don't forget to actually run the stuff at compile time. Yeah, only then the compiler can really tell you about your undefined behavior. But again, of course, people complain. I cannot add const strings in front of every function. So much of our functionality is not constexpr yet, and the compiler would constantly complain. Okay, true. You have to start somewhere, though. So yes, please start with the little things, and then you can go from there. But generally speaking, from a bigger point of view, it's the structure of your code. It's your design. You can make pretty much everything constexpr. You just have to pull the pieces apart so that this becomes possible. And a pretty impressive illustration of how this might work was given by Brian Ruth at CPBCon 2023. So he showed us how to think more functional and how to separate the different pieces into actions, calculations, data. And the green stuff, that's the safe stuff, in the end is the majority of code. That is pretty easy to make constexpr, and suddenly, well, indeed, almost all undefined behavior is vanquished. It can be easy. But, indeed, just as before, it's a mindset problem. It's a people problem. No matter what the problem is, it's always a people problem. So, let's take a look at type safety. Yeah, the third rider of the apocalypse. So for this purpose, I, again, start with an example. Let's take a look at this extrapolate position function. So extrapolate position. Extrapolate position, as the name suggests, extrapolates from a position based on some velocity and some acceleration. Yeah, I actually hope that when you see and look at this function, that you feel this cold shiver running down your spine. This, really? Seriously? And indeed, you might have a lot to complain. It's so easy to swap values. Yeah? Why is the t, the time apparently, the names are bad too, why is this a third? Is this natural? Is this intuitive? Probably not. I can't remember more than 5 parameters. Indeed, this is 7, and it has a natural limit indeed. Yeah, so there's also a core guideline that argues that you should have few parameters, not as many as possible. Then, there's absolutely no information about units. So does this function expect meters, seconds? Which units are used? And of course this will cause problems. Of course this will cause bugs. And then it returns via mutable references? Seriously? Just because x and y are 2 values? Okay, no. This is definitely not up to date to C++. However, again, not to misunderstand things, it never was. This always was bad, from the very beginning. Even since the beginning, say since C++ 98, what we do here is we use what we call strong types. We do not pass a bunch of doubles, we pass things with semantics, like a position. Now it's suddenly really clear what this does. Oh, our position. Then we pass a second. Oh great, the units are known too now. Then there may be a meter per second square second. Okay, you cannot complain about the names. Perhaps they're not particularly beautiful. But you see the purpose. There's suddenly information, semantic information on how we actually should work with this function. And also the call side gets so much safer because suddenly we cannot swap values anymore. That's what we do since the very beginning of C++. So this may be an example of such a strong type. Let's take a look at this class second. Class second. So first of all, it's not a lot of code. It never is. These strong types are pretty small usually. But they're pretty safe. So we have an explicit constructor, which is a must-have for just such a strong type. Then, of course, because I just said it, constexpr everywhere. No discard, because we can nowadays. So, by just writing such a simple struct or class, we suddenly have a lot more expressive code. So we cannot create a second and not just a double. However, you might still not be perfectly satisfied here, because you now realize that the 42 that I passed down here actually doesn't have to be a double. It would actually also work if you pass an int. Yeah. Type conversions. And the worst of them, the built-in conversions, the standard conversions. Ints just always convert into everything else when there is an opportunity. Very sad. And so, there's no way to control them, right? Or actually there is. And it's so simple. All we have to do is have to write one extra line of code. So, this line of code would go in front of the function. So before the constructor here, say this second constructor, we just add a constraint. So we now require that the given thing, the thing that you pass, is a double. Now, do you see what this means? You could pass anything, ints, unsigned, double, whatever, but as soon as it's not a double, there's a compilation error. And this means that you have to pass a double. You control it. And of course, I would do this for the next function too, because it's the same problem. You have to provide a double. So this prevents any kind of conversion. But now you might feel that this is perhaps a little too much. No kind of conversion. Is this limiting? Well, potentially, absolutely. But you're in control. If you want to take other things, good things, then perhaps you just check for narrowing conversions. This is the thing that definitely shouldn't happen. So you disallow narrowing conversions. You control what you want to take. You are in control. And that, again, is the philosophy of C++. So C++ doesn't give you safety, it gives you control over safety. You can do it. You can choose it if you want to. So, safety takeaway number 3, use strong types. So, now again, of course, people are pretty good at finding arguments against, right? And in this case, it's a most obvious argument. But what about performance? Aren't abstractions slow? Yeah, performance. Yeah, you can give people wonderful code, beautiful code, 100% safe code, but if it's not fast, people don't use it. So, is this slow? So I actually tested this in Compiler Explorer because it's simple. So I have a strong type called second, and I have an int. And I just let these two compete in a test function. So the function takes here an int, this one takes a second, does something, and then it returns the according type. So, take a guess. Is there any difference? No, absolutely not. These two functions really reduce to the absolute minimum. An addition done by a load effective address assembly instruction, it's exactly the same assembly code. There's no overhead whatsoever. And that's beautiful. So you can add safety on top of fast. That's the philosophy of C++. You can always add safety on top of fast. Great, amazing. So, I should say that Guy Davidson called this the superpower of C++. I think Kate Gregory did the same thing. So, they called abstraction the superpower of C++. I kind of agree. Really, there is a lot that we can do and that we should do in order to express what we truly want to do. So, still, you may have the question, do I have to write all of this by myself? No, definitely not. There's so many libraries out there that actually help you. So second is definitely something that by now you don't have to write anymore. This is already enabled as the standard library, since C++ is 11 essentially. But for everything else, perhaps meters, distances, velocities, accelerations, etc., there are good libraries. Like for instance, Björn Fahler's strong type library, easily found on GitHub. Very similar, but a little different, is TypeSafe from Jonathan Müller. And if you truly want to take a look at what might eventually, now look into the crystal ball, perhaps C++ 29 comes into the C++ standard, then check out Mateusz Pusch MP Units library. This is proposed for the C++ standard, and it's absolutely amazing again. It's fast, it's beautiful, it's simple, and you can combine units, get other units after that, so multiplying 2 meters gives you a square meter. It's a fantastic demonstration of what you can do in C++ today. So you should just be aware that this is bleeding edge. So this is not something that you can use C++ 14, 17, it's 23. But still, it probably should be because it's supposed to be in the standard. So, but still, it's so much more complicated. Well, if you're thinking that, okay, well, then my opinion is that some people just prefer to search for program errors for a few days and instead of spending a few seconds to add a helpful line of code. My take on that. So from my point of view, again, it's just a mindset issue, a people problem. All right, so next one, lifetime safety. Yeah, that's a tough one because that is something that it's definitely it feels like it's harder to control. And so to give you an example, I now go back pretty much 30 years. You may have seen this book. And yeah, I reference this often. Now, this is one of my most often shown slides. This is what we refer to as the Gang of Four book. Gang of Four because of the four authors who in 1994 published a book on patterns. So actually, they published 23 patterns in this book. Still, I would say that this is the most commonly used design patterns. And, well, 1994, it's a book, well, pretty much all. I think 21 of the 23 design patterns are based on inheritance. It's kind of expected at that time. So in this book, you, for instance, also find this visitor design pattern. So today I save you the introduction to visitor pattern. No. I just showed a picture. And this picture might already pretty much give away all these unfortunate details that this style of coding contains. So first, two inheritance hierarchies. The left one, the shape visitor hierarchy, and the right one, the shape hierarchy. Okay, so because of that, the performance is quite significantly reduced. Yes, in this pattern, you always have to call two virtual functions to do something. And people complain about a single virtual function very often. So two, yeah, that's definitely not a fast approach. Then, this design actually promotes dynamic memory allocation, which is not bad per se. But, of course, this means that we probably have many small manual allocations. And therefore, this means performance is affected again. Then, very, very often, we now have to deal with lifetime management. Yeah, once you allocate dynamically, you now need to manage it. Unique pointers come to mind. Again, you have to do something explicitly. You have to use a unique, or perhaps even a shared pointer. And again, pointers. Pointers affect performance as well. Yeah, it's an indirection. It's hiding something. And compilers can just not optimize this aggressively. Yes, and then, of course, the lifetime-related issues. The pointers. Pointers, null pointers, dangling pointers, uninitialized pointers. It's the major source of programming errors in our languages. Yeah, this morning I heard something like 90% of bugs go back to pointers and references. I kind of believe that. It's really difficult to do it right. So, however, again, this is not something that we just realized yesterday. So some people have talked about this for decades. For instance, Dave Abrams, who has talked about this really decades ago, then went to Apple, developed the Swift programming language, which, at least on the surface, doesn't have pointers and references. And now he's back in C++ and talking about this again. And in this talk, I believe he had a marvelous introduction with a couple of really, really good words. People, we have a problem. And it's one that we may not like to face. In fact, we maybe can't even see it because we're swimming in it. It's like water to the fish. I'm talking about reference semantics. So reference semantics, that's indeed the style of programming. That's this pointers, references everywhere. And he argues correctly, this is not what we do anymore and have been doing for many years. We prefer values. We prefer things that are simple, things that can be copied and moved because it's so much easier to understand, so much easier to cope with. So to give an impression, here's the modern version of this visitor pattern. Yeah, I've shown this many times before. This is your opportunity to take a short nap. So we may have a circle class. So the scenario is totally relevant. Say we have some circle. I know, just scan the code. There's no base class. There's no pointer. There's no allocation. There's no virtual function, pretty much as a consequence because there's no base class. It's really simple code. You can teach this on day 3 of a beginner's training, except perhaps for a few keywords like explicit. That doesn't have to be mentioned right away, but it's simple. Good. So that's what I said. Then, of course, there may be other shapes as well, but they're also just as simple. Then, operations, the visitors. That's a visitor. And again, no base class, no pointer. It's simple. So, then, and that's probably the core of the idea, we might use a stood variant, the modern form of the visitor pattern. And what is stored inside this variant are values. So we store a circle or a square. Nice. And then we work with values. So this function here goes through this vector of shapes, and it uses values. It traverses variant values, not pointers. There's no null pointer check necessary. Good. And then the most beautiful of all is the main function. We create a vector of values, a vector of shapes, which is creating circles and squares. Put them inside. It almost feels strange that I can add circles and squares to different things in the same vector, And that's pretty much the abstraction power of this variant. And again, it's simple. So, I believe this is beautiful indeed. And this is the style that we prefer today, the value semantic style. No base classes anywhere. No virtual functions, at least not on the surface. No pointers. And again, don't get me wrong, we use pointers, but in hiding. I don't know how the variant works inside. Probably I don't even want to know. They might use pointers inside, but we don't see them. We don't have to cope with them. No dynamic memory allocation on the outside. Good. And so this is why this code is just so much simpler. So much simpler, easy to maintain, etc. It's at the same time also much, much faster. Now, I've given an entire talk about this. So if this is interesting, then please check this out. I've given performance numbers also in 2022 at CPPCon. But also, I have talked about the other sides, the other forms of value semantics. I've also talked about what we call type erasure. So 1 year before that, check this out too, and then you might have a more complete set of the story. So, safety takeaway 4, prefer value semantics. So, but again, is this truly much better? Simpler, this truly is much better, simpler and even faster. But why isn't everybody using this? Well, again, I'm kind of repeating myself. I think it's a mindset problem. I think it's a people problem. However, okay, I get it. The language might not be perfect. We still have to do some homework, but it provides good solutions. So it's not a language problem. No, from my point of view, it not really is a language problem per se. Programming in C++ is unfortunately not safe by default. The by default may be seen as a problem. But we are in control of safety if we truly want it. And we have a couple of really, really good solutions to pretty much eliminate all of these common safety problems. So, pretty much most bound safety issues can be resolved by not using raw loops, by avoiding them. That's the style we use today. Then I would argue 99% type safety issues can be resolved by strong types in combination with any kind of constraint. And you know that even before C+20 you can do that. So, and I say 99% because if I would say 100, you would hold me accountable for it. Yeah. So if you find a problem still, it's the 1%. Agreed? So then almost all lifetime safety issues, approximately 99%, can be resolved by using value semantics. Indeed. And I believe all undefined behavior can be found and fixed by using constexpr and probably also the according sanitizers. So, and these are not new solutions. Absolutely not. Some of these solutions have been around forever, since the very beginning of the language. So why don't we use them? So, from my point of view, the real problem, it's a mindset problem. It is a people problem. So, some people just don't know. Indeed. So, in this case, you cannot complain. They just don't know how to do this stuff. So, unfortunately, too many still write a lot of classic C++. Classic C++ is the other thing, right? Despite our best practices and guidelines. And too many still don't use the tools that should be an integral part of every C++ project. The sanitizers, the testing tools, perhaps even just the online tools like Compile Explorer, CPU Insights, etc. So, but now, of course, you look at me a little confused, perhaps even a little angry, which makes this talk a little dangerous indeed. You look at me and complain, but Klaus, we do work according to these guidelines, and we do use these tools. Why do you complain at us? Okay, and that is the major problem of such a talk. I'm addressing the wrong crowd. You're the good guys. Just to be clear, you are the good guys. Applause to you, because you go to conferences. You actually want to learn. You want to improve. You might even occasionally pick up a book. Oh, great. You might actually read blogs about C++. You do your work. You get better. But you're an exception. You are exceptional to some extent. Because you're part of the bubble. I would argue that we live in a bubble. And I would now just estimate that this is like a 10% bubble. But it could be worse. Once in a while, I actually feel like it's even smaller. Perhaps it's a 1% bubble, somewhere in between 1 and 10%. So how do I know that? Well, you could go to YouTube, for instance. Every year at CPBCon, Bjørn Stroustrup gives a keynote talk. Every year. And for some reason, I believe it's because it's Bjørn, this is the talk that usually gets the most views. Yeah, nothing compares to Bjørn's talks. Bjørn has the most views. So the one from last year, 2024, has, and I checked this morning, 178,000 views. Whoa, 178,000! Amazing! But how many C++ programmers do we have? Millions of them. Millions. Still, absolutely. And the numbers is growing, absolutely. So, only a fraction, a small fraction of people actually care about what Bjørn has to say. So, this is not against Bjørn in any way. But perhaps there's truly just not enough people who care. And of course, I said this is the maximum. Yeah, the other talks, Herb Sutter's keynote talk, for instance, just gets 78,000 views. Yeah, so this is 100,000 less. So, I'm talking to the wrong crowd. You are exceptional, once again. You care. But of course, that makes you kind of responsible too. You have to spread the news. You have to help to tell the others that there is another style of programming today. So, Yanni could argue, isn't this a strong argument to start to use another programming language? Indeed, that's maybe the elephant in the room. But again, here's my opinion. Some people prefer to learn a new programming language for several years instead of spending a few weeks to probably learn their own programming language. So, okay. Then, some people don't know, but still speak up. And that's the worst. That's the worst indeed. So to just refer to a couple of experiences I have, or at least one experience that I had just last week. Indeed, on LinkedIn, I found somebody who officially claimed that C++ is not standardized, and that therefore you should use Rust. Seriously? Rust doesn't have a standard. C++ does have, and since, well, 1998. Oh, my bad. Sorry, CP. Okay, so this is just plain misinformation. And there's a lot of this. There is a lot of this. People just talk about stuff. They don't care. And so I believe this is actually a very devilish mix of total incompetence and just ignorance. But ignorance is bliss, right? Apparently. For some it is, obviously. So, but then, next, some people would like to know. So, and actually, we have a lot to offer here. For instance, books. A vast collection of good books. So, and this is just an impression. Yeah? Many, many books, nice, beautiful, and colorful covers. So, but still, let me tell you a story, a short story. I was actually doing a review of one of the books that has been sold for decades. Really, decades, so this was an update of an existing book. And then I found, very early in this book, the following statement. In many ways, programming in C++ is like driving without a road. So and I found this in, you will not believe it, chapter 7 out of 34. Seriously? This is how you want to communicate to beginners, to people who read the book, that this is C++? Seriously? So, is this truly how we want to teach C++? Is this the impression that we want to give people? Absolutely no. And so, since I was a reviewer, I objected. I wrote more than that, but this is kind of the gist. This paragraph sounds like it's a very bad idea to use C++. And that in chapter 7 already. This kind of thinking is the reason why C++ is considered an unsafe programming language. So I would strongly recommend to change the order of chapters. I would first teach the safe, right way, then how this stuff works under the hood. So people start to learn how to use C++ today, not how we used to use it in the 90s and 2000s. So from my point of view, this was good advice. But guess what? Yes, I was excluded from the review. So the book was sold, nothing was changed, and we still have the same crap that we had pretty much 20 years ago. So to give you two recommendations. Two, because I believe this is indeed good recommendations, I would recommend the two books from Francis Buentempo. So the left book is actually currently developed. This might take a while until it's done. But the right book is something that you can buy today. And I highlight these two books. There are many others, but I highlight these two because I like the style of programming there. This book teaches how C++ is used today. You will get to know algorithms really quickly. You get to know the features that are safe. You will not feel that everything is dangerous. It's good, it's safe, it's a simple code. This is exactly how it should be. And so I asked Frances to perhaps consider writing an introduction book. This is what she's currently doing. And yeah, it might be finished beginning of next year. And yes, this book teaches the safe part, how C++ should be used today. So in other words, yes, we can do better, but we should do better. But again, it's a mindset problem. So what can we do? So first of all, I can do my part. I can do my part as a C++ trainer / consultant. So I can go to people and say, this is how we use the language. Please try. And this works. My experience is that people like that people are happy about this. But then again, of course, I'm only invited by the people that are open-minded. Again, probably I might be talking to the wrong people. But then, it's about you as well. So we also need you. Because, as I said, you're exceptional. You're in this room because you want to get better. So please help. Please, if you have any colleagues, coworkers, etc., tell them that this classic C++ stuff is just not what we're doing anymore. It really feels like groveling in the dirt. So tell them to stand up, to be proud about the current C++, the new things, the safe, the easy things, and tell them to use the best practice and to use the tools that are just, well, it should be given nowadays. So, with our best practices and tools, we can easily remove the vast majority of safety issues. That's my opinion. But then, to finish quoting Herb Sutter again, if there were 90 to 98% fewer C++ type, bounds, initialization, lifetime vulnerabilities, we wouldn't be having this discussion. So, thank you very much. Thank you. So, we might have a couple of minutes for questions, if there are any. Oh, sorry. Do we have a mic for the recording? Okay.
Well, I do agree with you that we have a problem, and I do agree with you that when people use the most modern facilities from C++, we have way less problems with that.
Okay. So, stop. So he says he agrees with me for the recording. Okay.
However, I feel like you mostly shifting the blame from the language to the people, telling us that like at least 6 times that people are a problem, which is again true to the degree. And yes, we need to teach people, of course. However, I think the most important part is the tooling, right? And we do have a lot of tooling.
Indeed.
The problem is this tooling. We do not have a way to enforce this tooling on the regular outside bubble users of C++, right?
It's just the problem, right?
There are some initiatives into enforcing that. I mean, we can mention safety profiles, we can mention epochs and stuff like that.
Indeed.
That will be part of the language because if a person writes C++ code, they at least need to have what? A compiler, right? So my question to you is,
Okay, let me summarize the first part before I forget. So he always agrees, for the recording. But he says we should use more tools, and that's definitely something I agree with. He also says that C++ 26 will improve the situation even more, and 29, because the profiles that he mentioned are a white paper at this point. Okay,
right.
Now the question.
When it comes to the facilities that the language itself provides for us to limit the usage of unsafe part, what do you think on these facilities?
The language itself.
Yes, like safety profiles, for instance, or some rival proposals in this regard.
Okay, so we're talking about the future, because I pretty much talked about the things that you can use today. So, the question is, what do I think about the coming improvements of the language, safety improvements, for instance, the proposed profiles? So from my point of view, this is a pretty reasonable approach because it does something that no other proposal has done before. So this actually may be something that really affects everyone, and everyone can use without losing backwards compatibility. So we don't change the language rules, but we now give people something to say, yeah, I would like to change the rules for this and this purpose. Yeah, I want the safety profile. I want the embedded profile. I think this is a good idea. But it's controversial. It's not clear how exactly it should work. And exactly for that reason, it's currently a white paper. Yeah, so we can test this out. Yeah, compiler vendors could try something, then we can give feedback, and then evolve it into something that really works, keeping the community together. We shouldn't split the community in any way. Okay, other questions? Good. Then, thank you. Enjoy the rest of the conference.